this is how we highlight and chunk those Cornell notes. And then I may say compound more than one capital letter. Now I'm done with that first chunk, right? So what I suggest you then do is swap your highlighter color, just like we swapped our ink color. And I'm gonna draw my next chunk. Now biomolecules is a big chunk, so it's not even gonna end on the front of this page, okay? I'm just gonna start it as an example. Once I draw a box around everything that I wrote down about biomolecules, I then need to go in and reread it and highlight what I think is important. So carbs are important. They have CHO. They're for energy and structural support. I think that would be what is important within carbohydrates. Does everyone get the gist of what to do? All right, so I'm gonna set a timer for 5 minutes. In these 5 minutes, I want you to highlight and chunk your notes. Be sure that they get stapled together and then put them back in that front pocket. Thumbs up if you understand. All right, set a timer for 5 minutes. I need you to open your journals up to the next blank page, and you need to have this Venn diagram in front of you that you grabbed on your way in the door. I want us to take a moment and compare and contrast carbohydrates and lipids, because even like when we did that worksheet a minute ago, a lot of kids confuse which of these is fast energy and which of these is long-term energy.
Are we putting it sideways?
Yeah, I did mine sideways. You don't have to glue it in yet though. Right now you're just writing. We're not gluing. You're just writing. So label your Venn diagram. Carbs on the left, lipids on the right. Guys, have you ever poured some sugar into some sweet tea? Mm-hmm. Yeah. It tastes pretty good, right? It does that because carbs are soluble in water. That means they'll dissolve. Otherwise, I wouldn't be able to make sweet tea.
Did I say lower?
You work with me. I'll get there. I haven't gotten there yet. Okay. So carbs are soluble in water. Notice I've drawn for you a ring. That is the structure of a carbohydrate. So draw that ring.
Listen.
All right, guys. Stay with me. Do not try to get ahead of me. I am only right here. And truly, the only thing I've said is what you see right now. They are soluble in water, and their structure is a ring. So don't work ahead of me. Don't worry about trying to get that other stuff yet. Just do where I am. Now, carbs have lower energy per gram than lipids. Lower energy per gram than lipids. Now we can look at lipids. Lipids have more energy. I've drawn a long chain with almost like if I was drawing a stick man, that's his back and his legs. That's the overall structure of a lipid. So like a back and legs of a stick man. These have more energy gram per gram. Do y'all remember that word hydrophobic? It was from our Cornell notes. Hydro means water, phobic means what? Afraid. Lipids don't like water. They repel water. Now, look at what they have in common. They do both provide energy. And they do both have carbon, hydrogen, and oxygen. But if I were really trying to build up my strength, which of the two should I eat more of? Lipids and protein. But lipids are going to give me the long-term energy I need, right, for those lengthy workouts. So lipids are stored up energy. Give me a fist of 5 on this. How we doing? About 2 or 3. I think that's reasonable. Once you finish writing, go ahead and glue this in. I did turn my journal sideways and glue it in. All right, once you get this glued into your journal, you're going to go ahead and turn your journal back to the normal orientation. And we're going to flip to the next page. We're going to start up here with another quick Venn diagram. Looking at ATP and DNA. For whatever reason, I find this to be a big misconception for kids. They want to say that they're the same thing. Guys, is there anything in the middle here? So they don't really have anything in common. I guess what confuses students is that they're both 3-letter abbreviations. That's really the only thing I can think. So I want you to look at what each one of these things do so that you don't confuse them in the future. So my ATP is going to provide energy for everything, a body or a plant, anything that's living, it relies on ATP. Yes, ma'am, you're copying this down in your journal. ATP stands for adenosine triphosphate. Do y'all remember on Friday we talked about active and passive transport? So, yes, ma'am, you're going to write this in your journal. Active transport is against the concentration gradient. So with diffusion and osmosis, they kind of go with the flow, right? They're going kind of the normal way that things will flow just in order to balance out. But active transport's different. It's going to go against the normal flow. And because it's going against the normal flow, it's going to need energy. Have you guys ever been in like a pool at your house and walked in a circle for a long enough time that you made it your own whirlpool? And then you turned around and you tried to go the other direction? Or have you ever been in a lazy river and tried to walk the wrong way? It's the same idea. It takes a whole lot more energy to go against the flow than it takes to go with it. And then DNA carries and translates genetic information. DNA carries and translates genetic information. Remember, pro, no, you do. So prokaryotes have no real nucleus. Where is the genetic information in prokaryotes? Y'all remember? It's floating around in the cytoplasm, exactly. But in eukaryotes, we do have that nucleus. So like organisms like us, our DNA is in the nucleus of every single cell we have. So while most people want to confuse ATP and DNA, you see they're really not the same thing at all, are they? Give me a fist of 5 on having that Venn diagram. How we doing? 1. Lots of 1s and a couple of 2s. So we'll hang tight a second. How we doing? Do I need to zoom in? Would that help? Is that better? We literally have like maybe 4 minutes of writing left, and then we can close up for the day. So y'all hang tight with me. Everybody have the Venn diagram?
Yes.
Yes? All right, so we're going to look now at cell structure and function. There's 4 organelles that I really want you to know for our upcoming summative exam. And the first one is the vacuole. Vacuoles always store water. Sometimes I've seen the STAR test be tricky. Like when I think of vacuole, like I stereotypically think of a plant cell, but they can put a vacuole in an animal cell. But the vacuole in the animal cell is simply going to be smaller and less central to the cell than they are in a plant cell. Chloroplasts, those are only going to be in what type of cells? Plant, right? And those chloroplasts produce sugar. Which type of biomolecule is a sugar?
Lipids.
Not a lipid.
Carb.
Carbs. So sugar would be a carb. Mitochondria. Those are the powerhouse of the cells. Remember, mighty, mighty mitochondria. These convert energy. What is the energy used by cells? We just talked about it. It's 3 letters. Starts with A.
ATP.
Yes, it is ATP. And then the cell membrane. This is going to regulate cell contents. This allows water to move in and out. Do y'all remember what's the big long word I used to describe a cell membrane? Starts with a P.
Phospholipid bilayer.
Awesome. Will you take Alex 3 tickets? Thank you, Alex. Cell membrane allows water to move in and out of the cell. What can also be in that cell membrane? Do y'all remember? It's another biomolecule that can go all the way through it and works as like a bouncer. Starts with a P. Ends in protein. Protein. Good job. Great job. So proteins can be in the cell membrane and they can allow things to go in and out of it. The last thing we're going to write in our journal today is the word osmosis. Osmosis is the movement of water until solute concentrations on both sides are equal. Movement of water until solute concentrations on both sides are equal. Once you have this down, you can put your journal up. Leave the highlighters on the table. You can put up your glue. And Miss Neighbors is going to come around with a Post-it note for you. For your exit ticket for the day.